Good day, dear partners. Very happy to see you again, and thanks for joining QSAN online workshop. Today we will talk about QSAN storage in VMware virtualization. As we all agree, storage is a crucial component of each computer, server, and data center, including virtual environments. Proper storage configuration ensures optimal performance and reliability. When a data center grows and operates with large amounts of data, automation and scalability become necessary. VMware is still dominant in this field and offers the several advanced features where storage needs to ensure the seamless work via different level of integration. In today's presentation, I will introduce the integration of QSAN storages in VMware, and these integrations will help a lot to the IT administrators to simplify the storage management for large virtual environment, as well as the high availability configuration in cluster. It included VVOL, VASA provider, and clustered VMDK. If you have any questions during my presentation, just feel free to leave it in the chat room. I will be very happy to follow up afterwards. Let's start with short recap of VMware vSphere. VMware vSphere is VMware's virtualization platform, which transforms data centers into aggregated computing infrastructure. vSphere manages these infrastructures as a unified operating environment and provides you with the tools to administer the data centers that participate in that environment. The two core components of vSphere are ESXi and vCenter Server. ESXi is the virtualization platform where you create and run virtual machines and virtual appliances. vCenter Server is the service through which you manage multiple hosts connected in a network and pool host resources. Data Store is a storage space for virtual machines, and it can be provisioned either by internal storage of XSI Server or external shared storage array via mapping LUN by ISCSI and Fiber Channel or NFS share. Regarding the virtualization of storage, VMware developed vSAN that allows IT to build a hyper-converged virtual infrastructure using software-defined storage and abstract physical disk drives in ESXi servers. Also, more features were announced later to incorporate external storage arrays into this virtual infrastructure. The latter will be what we focus today. When traditional storage arrays were created years ago, storage vendors and software vendors decided to use LUN to map the LUNs, just as you would map a disk partition of a hard disk drive. The initial idea was that an operating system usually uses LUN as a single disk or as a shared disk for a cluster. When VMware developed its own VMware vSphere product, the company adopted LUN to connect shared storage via a network to ESXi hosts and format a LUN using VMFS, a cluster file system developed by VMware. VMFS is a reliable file system respected by users. Traditionally, a system administrator, a storage administrator, creates a LUN on the needed storage array, mounts this LUN to an ESXi host, and creates a data store using the attached LUN by creating the VMFS file system. The other way is raw device mapping, RDM. RDM is VMware's virtualization technology that allows a VM to access a LUN directly. IT administrators can then format the LUN using any file system, such as NTFS for Windows, eliminating the need to use the VMFS. RDM is generally most useful in complex or layered storage situations. For example, some admins prefer RDM when they run SAN snapshots in a VM and the SAN handles the backups. However, it also has some limitations. It doesn't map disk partitions and may not work on direct attached block devices. When a virtual infrastructure grows, and there are different types of disks, RAID, and deduplication configuration on storage arrays, storage provisioning may be required more frequently. Different VMs require different levels of service according to different policies, and the storage management becomes more difficult when you have hundreds or thousands of VMs. Historically, vSphere storage management has been based on constructs defined by the storage array, LUNs, and file systems. A storage administrator would configure array resources to present large homogeneous storage pools that would then be consumed by vSphere administrator. Since a single homogeneous storage pool would potentially contain many different applications and virtual machines, this approach resulted in needless complexity and inefficiency. vSphere administrators could not easily specify specific requirements on a per VM basis. Changing service levels for a given application usually meant relocating the application to a different storage pool. Storage administrators had to forecast well in advance what storage services might be needed in the future, usually resulting in the over-provisioning of resources. With VVOLs available from vSphere 6, this approach is fundamentally changed. vSphere administrators use policies to communicate application requirements to the storage array. The storage array responds with an individual storage container that precisely maps to application requirements and boundaries. VMware VVOLs is an innovative technology that delegates some storage-specific operations to the storage hardware side, such as SAN and NAS. In this case, storage arrays must implement support of VAE for their storage devices. Using VAI considerably offloads storage-related tasks from ESXi servers to the storage array's hardware and increases performance. A system administrator should define a set of policies to be used for different VMs when creating the VMs depending on requirements. When creating a new VM, the administrator should select a policy for VM storage. A policy is applied for VM objects using VVOLs on a per VM basis. Then, a LUN is created on the appropriate storage array for each VM object. Policy-based management saves time for vSphere administrators in large virtual environments because admins don't have to search manually for a suitable storage target for a VM among available storage arrays with free space. VASA Provider, now supported by QSAN, is a storage-side software component that acts as a storage awareness service for vSphere and mediates out-of-band communication between vCenter server and vSphere hosts on one side and a storage system on the other. vSphere hosts and vCenter server connect to the VASA provider and obtain information about available storage topology, capabilities, and status. Subsequently, vCenter server provides this information to vSphere clients, exposing the capabilities around which the administrator might craft storage policies in SPBM. Through VASA Provider, the storage system becomes aware of the VVOLs and their associations with the relevant virtual machines. Here is the comparison between traditional storage and VVO. Rather than arranging storage around features of a storage system, VVOLs arranges storage around the needs of individual virtual machines, making storage virtual machine-centric. VVOLs map virtual disks and their respective components directly to objects called VVOLs on a storage system. This mapping allows vSphere to offload intensive storage operations such as snapshots, cloning, and replication to the storage system. An administrator can simply create a storage policy and selects the VMs to which he wants to apply that policy. The system then automatically recopies different VMs and VMDKs to the data stores that meet the policy's conditions and alerts the administrator if his VMs aren't compliant. Benefit becomes significant when the VMware environment grows in scale and complication, especially heterogeneous storage, and such automation ease the storage management for admin. While VVOL and VASA Provider offers significant benefits for storage management in overall virtualized environment, there are also continuous improvement in specific applications. From vSphere 7.0, clustered VMDK was introduced to simplify the storage management in the application of Windows Server Failover Cluster, WSFC. So what is clustered VMDK? Basically, it is a VMDK shared by clustering solution on a VMFS volume. In the past, this was not possible, especially in Microsoft Cluster Service or Windows Server Failover Cluster. By VMware, we can enable clustered VMDK by SXE 7.0 or later and are managed by vCenter 7.0 or later. USFC is a set of independent servers that work together to improve the availability of applications and services. When a cluster node or service fails, the service loaded on the node can be automatically or manually transferred to another available node in a procedure called failover. When deploying WFSC in VMware before vSphere 7.0, WSFC on vSphere has always required the use of RDM disks. This is due to the fact that WSFC uses SCSI3 PRs, persistent reservations commands, to coordinate access to a clustered disk resource. It essentially uses this command to lock the volume so only the active node is allowed to write to it. But because VMFS has its own locking mechanisms, these SCSI commands are intercepted and discarded with traditional virtual disks. Hence the need for RDM disks acting as a mapping device for the physical LUN. Managing these RDM disks isn't that big a deal, but it represents an exotic configuration in the environment, and you have to be in sync with the storage team. It adds a bunch of LUNs, host boot times are longer. Things are better since vSphere 6.5 that added the ability to vMotion running WSFC nodes. Anyway, vSphere 7.0 brings this amazing new feature, clustered VMDK, that allows SCSI 3PR commands issued to a virtual disk, meaning you will no longer need a dedicated physical LUN to spin up a Windows failover cluster. Another benefit of clustered VMDK over RDM is the performance. According to the QSAN lab report, QSAN storage with clustered VMDK support delivered the better throughput in sequential workloads. Here is the summary of QSAN integration with VMware. QSAN's full range of products were certified and listed in VMware HCL, and we continue to enhance the integration with VMware and other hypervisor solutions to make virtualization architectures efficiently, and all your workloads can be integrated and accelerated. Okay, thanks again for all your attendance today. If you have any questions come up after today's webinar, please feel free to contact me or our local partners in Americas. We will be always happy to hear from you and assist. Have a good day and look forward to seeing you soon next time.